Okay. So here, right, we dealt with this before. We got the area to the left of 6.5, right? Here, this was actually an earlier one with the test scores, okay? Test scores are out of 10, normally distributed. The mean is 6, standard deviation is 0.3, right? We did that already. We already did get the area to the left of 6.5, right? Remember we did this? We got the z-score, which is about 1.667. Okay. We rounded that to 1.7. We got the area to be 0.9554. But if we want the area to the right of this, that is, we want the percentage of students greater than this, the percentage of data values larger than this, we have to do 1 minus the area. See, that's what we're doing here. 1 minus the area. This stuff here, remember, we did last time. From the table, you get the area to the left or less than the z-score, which is about 1.7. The area less than that is about this. So the area greater than that is about 1 minus that, which is 0.0446. Okay, so that's what we get here. Okay, all right. So we have this one. This one I was going to have everyone try, but let's just do it together. Here we have the same data actually actually it's slightly different. So I guess it's a different test where the test scores are again out of 10, but now that it's normally distributed with a mean of 5 and a standard deviation of 0.5. Now the question is, what percentage of students scored greater than 6? Well, again, what do? We have to get the z-score. So again, we're looking for the area larger than 6, to the right of 6, greater than 6, I mean. So let's get the z-score. We have 6 minus 5 divided by 1/2. That's 1 divided by 1/2, which is 2. Now, if you did look in the table, right, the z-score 2 in the table, again, it's in the textbook, you would get an area of 0.9773. Okay, 0.9773. Now, so that means the area to the left of that z-score, less than it, is 0.9773. The area less than it. We want the area greater than it, right? Greater to the right. So we do 1 minus that. And we get this. So in this case, the percentage of data values greater than 6 is about, it's about 2.27%. Remember, you have to convert the area to a percent. Okay, we want percentage. Okay, that's what we're looking for. All right. Yeah, are there any questions on this one? Yes.
So when you convert to a percent, do you convert like, for that example, like the 0.9773 to a percent, or the answer, like the
answer?
The answer to, okay.
Yeah.
Yeah,
I mean, you could, oh, sorry, keep going.
No, I was just like confused. I didn't know exactly what like when I was converting.
That's a really good question, actually. I'm glad someone asked that. You only convert to a percent, you convert the answer. Okay? I mean, the thing is, if you converted this to a percent, you would have to convert the 1 to 100%. If you forget to do that, you're not going to get the right answer. So you only want to convert at the end. So really, very good question. Okay. All right, cool. Okay, good question. Any other questions? Okay. All right. So we got the area to the left of the z-score, right? That's from the table. We can get the area to the right. Essentially, you get the area to the left and do 1 minus, right? But now, let's consider this scenario. We have two different z-scores. You know, I called them z1 and z2. And as in this graph, I should say, z1 is smaller than z2. How much smaller? I don't know. They both could be positive. They both could be negative. It doesn't matter. Let's find the area between them, right? How would we get this area? Well, what if we took, well, what we can do is this. Since z2 is bigger, we can get the area to the left of z2, okay? And we subtract off the area to the left of z1. What you'll be left with is the area bigger than z1, but still less than z2. So yeah, maybe this will help. If you imagine we're looking at the area to the left of z2, right? This would be shaded in for going to the left forever. But if you subtract off the area to the left of z1, this piece here is gone. You're throwing it away by subtracting. And what's left over? This wonderful piece. So that's what you do. Area less than z2, you subtract off the area less than z1, and you're left with this. All right. So as an example, let's suppose this was also from the book. We have an annual rainfall in a certain region, and they tell you that the data here is approximately normally distributed. You know, the mean is 33.5 inches, standard deviation is 5.6 inches. So let's get the percentage of data values here. So for less than 30, right, what do? You have to get the z-score, right? Basically here, you have to get the z-scores. The mean is 33.5, standard deviation is 5.6, right? So we have to, and here we have 30. So we do 30 minus the mean divided by the standard deviation. And if you do that calculation, you get this, which turns out to be this. Now we have to stop here because I'm running out of time.